Okay, so in this question we've got a bottle of ink that's tipped over and it's spilling on the floor and it's causing a spill which is round. And we have to calculate the percentage change in the area of the spill when the radius goes up by 2%. Okay, so there's our radius there. And of course we know that the area of a circle is pi r squared. So we need to find out how much that area changes. Actually, not how much, but the percentage change. Now, percentage just means you multiply the numbers by 100. So we'll get to that later. Okay, so what we do know, actually, let me draw a picture here to show you what that looks like on a graph. So we've got this graph here. I don't exactly know what it looks like. Actually, I don't exactly know what it looks like because it's pi r squared. So that's nice and easy, right? So it's r and a. So it's just some sort of quadratic parabola. And what we're looking at is that when we've got this r value here, and it goes up by a little amount, how much does this a value go up? Okay, so we know this is actually... Okay, now I'm going to be careful here. This is going up by 2%. So let me just say, so delta r is this side here, and delta a is this area here. But it's not saying delta r is 2% or even 0.02. It's just saying it's going up by 2%. Okay, so let me just write plus 2% there. I'll show you what that means. Okay, so what we know is, let me write that out for you. So what that means is that delta r divided by r is 0.02. Okay, so that's where that 2% comes in. It's not delta r itself because we're saying it's the percentage change of the radius. So it's definitely 0.02 or 2%, but it's delta r over r. We're going to need delta r later, so let's rewrite that as 0.02r. Okay. And, okay, so we need to find out the percentage change in A. So again, what are we looking for? So when we do this, just if I do some scrap notes here, at the end, are we going to get what? Delta A? Not quite, because again, the same thing applies. So it's not just delta A, we want delta A over A. Okay, because that's going to be the percentage change in A. That's what we're looking for. So we're going to end up with something like delta A over A equals something. Okay, so let's see how we get there. So we know the area of the circle is pi r squared. So this is where that rule of small changes comes in. So that formula says that delta A over delta R is approximately equal to dA dr. Okay, now we're looking for delta A over A. So let's move the delta R to the other side first. Now we can't change dA dr, that's just an expression, but we can move that delta R up to this side. And remember what we want is delta A over A, so let's divide both sides by A. Okay, so this is going to be a formula that we're going to use, and all we now need to do is substitute the values. Okay, just need to calculate the values, which is pretty straightforward now that we know what we're working towards. So dA dr, okay, so A equals pi r squared. Let's go back up here. So therefore dA dr equals 2 pi r. Delta R, we've calculated here, 0.02R, and A, we've got here, pi r squared. Okay, now let's see what we've got. The pi's cancel out, that's nice. In fact, the r's, there's 2 r's at the top there, so that's r squared and r squared. So we just end up with 0.04, okay, or 4%. Okay, so that's our answer. Nice and easy, right? Okay, now there's a second part of the question, and the second part says, what's the change in R when A changes from 100 to 105? Do this in centimeters squared. Okay, so we need to find out delta R this time. They don't want no percentage change, they just want no change, and we know delta A. Okay, so let's use that formula again. In fact, now this is a bit silly because really you don't need to use that. Even if you didn't know any calculus, you could figure this out because here's A, so let me draw this for you here. It's just a bit of an aside. So we've got A changes from, let's say, 100 to 105. Obviously, this is not to scale. So we just need to know what the changes in R are. So we've got R1 and R2. And that's pretty easy, right? Because we know it's pi r squared, so we could figure out those R values and subtract them, and that gives the change. So that would be the logical way to do it. But we don't have to be logical. We are asked not to be logical here. I think the more logical thing to do would be to pick up the bottle of ink so it doesn't spill anymore. But we are asked to use calculus techniques to figure this out. So we can't just do it that way. But we can use our formula again. So we know that the area, now we need to get the change in R, okay? So we've got, let's use our formula again for small changes, delta A over delta R, approximately equal to dAdr. And we're trying to find delta R here this time, so let's bring that across to the other side, and bring this one around to this side. So we get, let's rearrange this, delta R equals delta A divided by dAdr. Okay, we can't flip this around because it's just dAdr, that's just the expression. Okay, so we know that delta A is 5. Okay, that's pretty straightforward. And we know dAdr, so we've got 5 over dAdr is 2 pi r. Okay, now the only thing that we don't know is what the R value is. So, but we do know this because we can calculate it from here. We know that area equals pi r squared. So R equals plus or minus square root of, what's it, area over pi. We can forget about the negative one because we're not going to have a negative area. So R equals the square root of 100 over pi, which equals 10 over square root of pi. Okay, and plug that back into here. We get R equals, what do we get, 5 over, sorry, delta R, 5 over 2 pi r. So let's flip this one over, made a mistake there, should be root pi over 10. That 5 and that cancels. That root pi and that pi gives you a root pi on the bottom. So you get, 1 over 4 root pi. Okay, it's an unusual number, but let's say that's right. Which equals, now I can plug it into the calculator, and about 0.0414 centimeters.